Practical application of microbit in programming, variants, and iterations. Main objectives of the lesson. Perform arithmetic operations. Work with coordinates, in Python. Create graphics, and apply animation. Run iterative commands. What have been discussed in the previous lesson? The microbit is a pocket-sized programmable microcontroller unit, MCU. Developed to facilitate learning by helping learners understand coding and electronics. Versatile for various projects and activities. Let's start, and know the main parts of the MCU. At a glance, the main parts of the MCU. LED array. Button A. Button B. Analog digital input-output. Let's review some information. Overview of microbit, a pocket-sized codable computer, 25 red LEDs that light up, flash messages etc. Designed to make learning easy, has 2 program buttons. Main features. It can be used as a game controller such as Kudo. Embedded Bluetooth for wireless connectivity facility, built-in compass. Let's know arithmetic operations. Arithmetic operation. The commonly used arithmetic operators are addition, subtraction, division, multiplication, exponential. Arithmetic operation example problem. Arithmetic and Python notation differ in exponential form only, otherwise they are similar to each other. This example problem demonstrate addition and exponential operation. In this example, firstly 2 variables x and y has been declared and numerical values assigned to it. The arithmetic and Python notations are shown separately. The print command displays some values on the LED matrix, the output shows the sum 7. Notice that both the notation and addition operation for arithmetic and Python operators are similar, whereas in the exponential operation, the operator is different. Syntax shows the different notation. Let's know how to write equations in the programming language. Microbit can perform several mathematical operation, mathematical equation, written in arithmetic notation equation, written in Python notation. The 2 equations show the difference between arithmetic and Python notation. Let's practice Python notation problems. Practice problems on Python notation. Write a Python expression to evaluate 5 plus 3. Write a Python expression to evaluate the product of 5 and 3. Write a Python expression to evaluate 5 divided by 3. Write a Python expression to evaluate the exponential value 5 raised to the power of 3. Stop the video, and play when you are ready to see the answers. Solutions to the practice problems. Let's know microbit coding for arithmetic operations in MakeCode and Python Editor. Microsoft MakeCode Editor. Before starting the coding, let's understand the MakeCode Editor layout, its features, and interfaces. MakeCode Editor is developed by Microsoft for microbit. It has emulator at the left side and code editing window at right side. It supports JavaScript and Python programming languages. It consists of blocks. Blocks contain built-in function. Basic block contains various built-in functions, such as show number, show LED, and show icon functions. Input block contains various built-in key pressed functions, such as button press A, button press B and shake function. More block contains various built-in magnetic, compass and calibration functions. Music block contains various built-in music, and customizable melody functions. Similarly, math block contains arithmetic operators and logic block contains if and else commands. It has code download facility to save the code. Let's start using the blocks along with JavaScript to perform arithmetic operations of 4 plus 2. And here are the steps. Now let's learn the actual procedures. Microbit coding for arithmetic operations in MakeCode and Python. Declaration of variable, num1, and dragged onto the workspace. Variable num1 equals 4. Declaration of variable, num2, and dragged onto the workspace. Variable num2 equals 2. Dragging show number function from basic block. Dragging arithmetic operations option from math block. JavaScript code, updating, num1, and num2 declaration and show number function. Addition operator, num1 plus num2 equals 6. Subtraction operator, num1, minus, num2 equals 2. JavaScript, Python code for subtraction operator. Multiplication operator, num1 multiplied by num2, 4 into 2 equals 8. JavaScript, Python code for multiplication operator. Division operator, num1 divided by num2, 4 divided by 2 equals 2. Exponential operator, num1 raised to the power of num2 equals 16. Now let's practice some problems. Stop the video, and play when you are ready to see the answers. Let's move to coordinates in microbit. Coordinates in microbit, microbit LED matrix coordinate XY. LED matrix has 5 by 5 setup equals 25 LEDs. Let's learn the LED matrix coordinate, and know how to write code in Python for turning on some of the 25 LED lights to show numbers 1 to 10. How LED matrix coordinates work in microbit. The coordinate of LED are assigned with column and rows numbers. The LED turns on when the corresponding XY coordinate is assigned with 9 number, it turns off when it is 0. The number 9 gives full brightness whereas number 1 gives minimum brightness. The display shows one number, as per the coordinate or assignment accordingly with 9 number. The arrows indicate the LED position for column and rows to show number 1. There are 5 column and 5 rows. Stop. Any questions? Displaying numbers, 0 to 9 in Python programming language. The following Python code displays the counting 0 to 3. 0. Stop the video and find the match between the code and LED lighting for displaying 0. 1. 2. Stop the video and find the match between the code and LED lighting for displaying 2. 3. An example of the correct code display 1. Now, work out the practice problem for X and Y coordinate code for 5. And check out the code with correct code at the end. Stop the video and play when you are ready to see the answers. The correct answer. Let's move and start. For creating a graphic object. Creating graphic object using microbit. Follow these steps to create heart shape using JavaScript. Step 1. Open the microbit MakeCode editor by visiting the MakeCode microbit.org website. Step 2. After visiting the website, click on the New Project button to create a new project. Step 3. Select JavaScript as the programming language. Step 4. Type the project name. Let's know how program in JavaScript to display heart graphic object in MakeCode editor. More coding examples. For drawing hard and different objects using blocks, click the Basic tab. Drag and drop the Show LEDs block onto the workspace. Then in the Show LEDs block, click on the squares to draw a hard object. The JavaScript code automatically draws the hash symbols. The hash symbol in the code turns the LED on, whereas the dot symbol turn it off. The LED block can be cleared by clicking the white squares. To draw a rectangle on the LED matrix, click the boxes as shown. The JavaScript code automatically draws the hash symbols. Clear the LED block. To draw a triangle, click the boxes as shown. The JavaScript code automatically draws the hash symbols. Any image or object can be drawn using LED block in MakeCode Editor. Program in JavaScript to display hard graphic object in MakeCode Editor. Visiting website. Creating new project. Selecting JavaScript. Project name. Type the project name in the project namespace as hard graphics. Dragging Show LED block from Basic block list. Entering the LED, on, off data. Hard image on LED display. Let's learn how to make your name badge. Code to display the name on the screen. On button press A. From the input toolbox, drag button a pressed function block onto the workspace. From the basic toolbar, drag Show String block on the on button a pressed block. LED display shows animated my name string. Let's stop and know the steps to animate the graphic object on the LED screen. Coding steps to animate the object on LED screen. Import the necessary module. Define the pattern of the graphic object to move. Use a loop to move the position of the graphic object on the LED screen. The object can be moved in any direction, using Shift Up, Shift Down. The conditional statements can animate the object on user input response also by using while true. Let's move to indentation. What is indentation? Indentation is the leading whitespace before any statement in Python. Whitespace is either a tab or a space in your keyboard. Rule of indentation. Rule number 1. Minimum one space is necessary to represent an indented statement. Rule number 2. The first line of Python code cannot have indentation. Rule number 3. Indentation is mandatory to define a block of code. Rule number 4. The number of space must be uniform. Let's see an indentation block example. Indentation block example. The indentation example shows, while true, and for loop, indentation, with first level, and second level of indentation. Iterative commands in microbit using blocks, JavaScript and Python programming languages. The following example shows sprite moving backward on button pressed, and forward on B pressed. Let's know the example of moving the object on LED screen. LED screen shows sprite animation. Button A pressed move and turn right. Button B pressed move and turn left. Iterative commands in the microbit, while loop or for loop. Loops repeat a block of code multiple times. MakeCode for microbit have built-in support for loops and conditional function. You can use loops and conditional statements to create these functionalities in your code. Let's know the differences between for and while loop. Loops supported by microbit. Differences between for and while loop. Initialization. For loop initializes the variable and sets it to an initial value, whereas, while loop execute a block of code until specified condition is true. The syntax for loop includes the and keyword and the sequence being iterated over, but in while loop, the while loop has a more flexible syntax. Number of iterations. For loop is used when the number of iterations is known. In while loop is for unknown iteration. It is typically used for counting. For loop is usually has a local scope, whereas while loop has wider scope. For loop example. Clicking input block. Placing button press a function on workspace. Declaration of variable I. Placing for loop function inside button press a function. Placing variable I inside for loop function. Placing show number function inside for loop. Placing variable I inside show number function. 0 is initial value. 4 is condition true value. While a loop example. Clicking input block. Placing button press a function on workspace. Drag while loop function block. Drag comparison function from logic block. Drag variable second from variable block and place it inside comparison block. Place comparison function inside while function. Set value to less than or equal to. Set condition value for. Drag and place show number function inside while function. Drag change variable from variable block and place inside while function. Drag variable second from variable block. Place variable second inside while function. Emulator displays counting from 0 to 4. Infinite iteration loop in Python. Infinite iteration loop is a loop that runs forever, conditionally looping and executing its block of code without stopping or breaking out of the loop. It can be stopped by while loop true condition. To stop the indefinite loop, follow the steps shown with while loop code. It's time to evaluate and discuss. Let's stop and review what we learned. Can you perform mathematical operations? Can you coordinate in a microbit? Can you create and move graphic objects? Can you implement repetition? Now it's time for the activities group. Let's stop. Take 8 minutes for each activity. Activity 1. Calculate the result of the arithmetic operations on paper first, and then apply these operations in Python. 5 plus 6/3 multiplied by 12. 3 times 60 minus 20. 20 plus 5/4. Activity 2. Create a program that uses the microbit sensors, buttons, or LED display. The program should demonstrate variables, loops, and conditional statements. Use MakeCode to create your program and present the project to the class and explain. Activity 3. Identify the parts. Let's stop here and get some additional references to help you learn and get more information about variants and iterations.